just count as half since it's like
One more. And then to check to make sure it
Yeah, so we
doesn't
did 4
spill.
together. 1, 2, 3, 4, 5,
Ah.
6, 7, 8, 9. Yeah, that's good.
Where are you going next?
Although you're out of time either way,
Maybe
so.
another calc quiz tomorrow. What? Did you say I'm out of time? Oh, you want fun. We have one tomorrow, Mr. Thompson.
Yes.
A quiz tomorrow? Another one?
Every day. They take like 2 minutes. It takes me like an hour to make them and make copies and make an answer key and put the grades in. Y'all take 2 minutes to work it and 5 minutes to review it. Unless you don't remember it, and then that's a different issue.
I remember.
If you don't remember it, you need to relearn it. So.
What are you doing?
She's trying to finish with 30 seconds left.
I have 4 minutes. She's on 14, so she's good. Well, and I have most of them
Are
done.
we turning the circuit or no?
If it's, it
Yeah.
only has to be halfway done.
Yeah. So are we turning around?
Yes. It's number 3 on the agenda. I'm just gonna have you turn it in with your mini quiz. That way you only have to turn
I
in
can't
things
remember all
once.
this information. I need some help this one.
You don't have to have all the
I know, but I want the extra points because I need it.
We get extra
all.
points for having it done?
Yeah.
You did all of it, you get a second off.
So look, I got
Too late for me.
I got 5 again.
It just doesn't help. Like,
But
never
I
mind. I took
already
only my grade up. This is about to
That 2 wouldn't be there that way.
totally
You're gonna do this derivative this way, you gotta do chain rule.
I know.
I'm scared.
Yeah.
We have another one tomorrow.
Honestly, what I'd do is just bring the 2 down from
I
one.
tracked me tonight too.
Are
So
you going to one far away?
another one
That's a lot easier than having to worry about
Yeah, so it's nice. Like, and it's just relay. So
the 4 questions we did together plus half of the rest. So that's like 13.
It took
tomorrow, but
I did it like in an hour.
I have exactly 13.
It was easy.
And then 3 of these I forgot.
So I was like, oh, we should have that.
I'm not taking that up yet. We're doing another one today.
But I haven't done that. Or the
What's the, like, FRQ thing?
I'm just worried because this is gonna be thrown in.
It is, I don't know if I have a copy over here. It was,
I think I might have that.
it was 3 practice FRQs from the last unit. I gave it, I gave you several classes. But, so I'm not giving you more homework time for that because I asked you to do it. I have it done, but I'll take it up tomorrow.
So you're not taking up the other piece today? I can't do there. That's what I got to.
You know it has to equal 1. Oh no, not today. Tomorrow.
What?
Yeah,
The
what's
FRQs?
the last one.
Uh,
This is the last.
He's asking about something else.
How many are there?
18 or no. How many total numbers?
How many total numbers? We'll probably get up to like 160.
What? No, on the circuit, on the circuit. Like, what's the last number?
1.
No, like,
The answer to the last question is 1.
oh yeah, 1.
Is it just the circuit that's
That's the only one I'm taking up today, yes.
Yeah.
And the other one's due tomorrow.
The other what?
The FRQ pages.
I will take them up tomorrow, yes. Y'all make this way harder.
There's
If
just so
you-
much stuff to keep track of.
But if you do, when I say
But
do
I
this
missed-
for homework, if y'all do it for homework, then you have it ready when I ask for
Yeah,
it.
but I
If
missed,
you number
I
the
missed
assignments,
Tuesday. I missed Tuesday, so then I was like trying to figure out.
I have the whole class recorded. All you have to do is watch the first 5
I can never
minutes.
find those recordings. That even when I like control F it like it just doesn't like load them all. It's like so I just do on the what's on the agenda usually.
You wait. Look, I made it easier for you.
Match these.
Half of it, but I'll let you go. Oh, wait, here's the quiz. But I'm not official. I didn't finish.
Okay, this is the page you go to, right?
Yeah.
Oh my gosh, man, it's so slow.
Is room 16 the upper use?
So what do we have to turn on?
No, I will verbalize it all in just a second. I gotta take it off screen. Okay,
For kids, right? For tomorrow.
right here.
Oh my gosh, what?
But it's these ones, dude.
Right here, Ashley.
Yeah. The calendar.
April class recordings.
Oh, yeah. Is that thing new?
Yes.
Okay.
All you have to do is click
That's a
on.
lot easier.
Yes, the exact class. You can't miss it.
Oh, this circuit. Yeah.
Okay. You guys don't need to turn anything in yet. If you did already, that's fine. But remember, we have our mini quiz first. So clear off your desk.
We can finish this though.
How you doing your advisory? Oh. That's what I was doing.
I will verbalize everything that you guys need to turn in and say. But I will also add that if you guys have not continued numbering the stuff for your binder, then it gets more and more confusing. Some stuff sounds similar to other things. Just number them. Okay, so you don't have to turn your phones in to the front of the room, but just make sure that you don't accidentally grab it until you are finished and turn this in. Okay, the reason why I said you didn't have to turn anything in yet, I didn't have that under bell work today. When you turn in your mini quiz, which is 116, you should number it so that you can keep up with what's going on. Then you should turn in one thing that you've done for homework, which was the circuit, which is 110. So you can just turn them both in at the same time, instead of turning in two things or one thing twice. sorry, I meant to say this about the directions, but you guys probably figured it out. I put all the answer choices on the top of the front, and then I re-pasted them on the front of the top of the back as well. So I was trying to make it where you didn't have to flip back and forth as much. But you probably have figured that out by now. Just like the first one, every question has one answer. There's no distractors, no duplicate answers. So a good strategy would be saving the ones you're least comfortable with to the end and using process of elimination to help out. Rush anybody here, but for those of you that are finished, make sure that you're turning in the mini quiz and the 110 circuit. Should have gotten what was at least required done in class last Thursday. And then while you wait, one of your handouts today is 117. When you see this is what you do, part 3. And that might be the last one.
It says 117 is the library, not 1.5. So what's the difference?
Sorry, the live review should be 118. I was looking at the first part of the homework is what I was referring to. Those of you that are finished and you're just waiting, you could start that. you're still working on that, that's fine, but try to finish up here in just a minute, and then you'll need to catch up with the rest of us. So let me say it one more time here, just to make sure that you don't get docked any points from not reading the board or hearing me the first couple times. But 116 was the mini quiz you just turned in. I need that. And then 110 is the other grade that I'm taking up today, which was the L'Hopital's rule circuit from last Thursday. So if you didn't get that one in when you turned in your mini quiz, you need to do that before you go to lunch. Okay, we got two things we're going to look at today. So next up is 115. So that's the FRQ packets that you guys had. We did 2 of those together last class. I'd like to do 1 more of those today. Now remember, part of why we started with this one is these are the most common FRQ types. Now, of course, not every part of every one of these is the same. Some of them ask limit stuff, some of them ask other things, but they all had that finding the area under the curve manually with triangles and quarter circles and half circles and all that kind of stuff in common. So we are on the 3rd one of those, the one that says 2017 FRQ3. So it's the one that looks like this. It's on the 3rd page. And I don't know. It bugs me when I don't know the average of these things. I don't know if it really matters so much to you, but I had to relearn where they have that information. It's actually hidden on AP Classroom, and I don't know if you'll have access to it. But if you're interested in those kind of things, this one has an average of 3.63 out of 9, of course. And so this would be the one practice FRQ I would like y'all to do today. And as we've been doing, I'd like to actually give you time to try it, to give yourself some real feedback. So any questions or anything before I set a timer and give you 15 minutes to try it first? Okay. Then 15 minutes from now, I'll show you the answers. We'll discuss what we need to discuss, and then we've got one other thing I'd like to get done in class today. 6 minutes in and have 9 minutes left. Got about 4 more minutes. 30 seconds. Okay, time's up. So it looks like 15 minutes was a little more generous than it sometimes is. So, but that's okay because it's just an average. So let's quickly go ahead and see how you did out of the 9 points. Again, when I take this up for participation grade, I'm not going to dock you, but hopefully you feel a little bit better about this one. Partly because finding the area was kind of expected at this point. And this average was just a tiny bit higher, so that should have meant that it's a little bit easier for everybody. But part A, you get 1 point if you use the initial condition. So in the directions there, they told you at f of -2 at 7. So if you use that in part A, you get a point. Even if you don't end up with the correct answers, you still get that. And then second point comes from getting the first answer they were looking for, which was 3, or 7 minus 4. You can't stop here. You can't not do the algebra and calculus, but you can choose not to do the subtraction at the end, I guess. And then the third point came from finding the other answer they wanted, f of 5, which was either this or this. If you didn't combine the 7 plus 3, that's fine. Okay, so we'll do the math questions later, but any questions about the grading on that? Okay, then part B, 2 points, all or none here. You needed to say these intervals, those are the 2 places where it is increasing. Now, if you did parentheses here instead of brackets, that's fine. In fact, I would always suggest you use parentheses when you're doing increasing, decreasing stuff. Okay, and and you have to have justification though. So you have to have those 2 intervals, and you have to explain it correctly. So saying like the derivative is positive there is probably the quickest way to justify it. Any other questions about that part? Part C, find the absolute minimum. So that's extreme value theorem. So notice they tested the endpoints, -6 and 5. And they tested anywhere where it's changing directions, which in this case would be where it's crossing the x-axis, -2 and 2. This is what's called a candidates test. And the candidates test is the easiest way to do your justification. Short of a paragraph explaining why you tested these points and not other points, and not overlooking anything, that's very hard to do without a candidates test. So make sure that you're making those. Okay, but you get 1 point if you even considered x equals 2. So even if you didn't use it correctly or you answered the question incorrectly, if you considered x equals 2, you get a point. And the other point, you have to have figured out that the minimum was at this value. It didn't say when, it said what the value was. And you have to justify it. So if you did this candidates test where you showed that you tested the endpoints and the critical numbers, then that would count as the justification. Okay, scoring questions there? Yeah.
So theoretically, if we did do like a paragraph explaining why we tested some and not others, could we still get a point for that?
You could, but it's a very slippery slope because you have to explain, I mean, in your paragraph, you should be explaining x equals 2 and x equals +2 and finding those values. And if you're not testing one of those, you would need to be explaining why you're not testing those, why you don't think they're important. Like, I don't think anyone tested x equals 3. So if you thought you should, you'd have to justify that. I don't know. Candidates test is by far like in your paragraph, you'd basically be explaining the same things. It's just that a lot of times you guys you'll say a sentence or two and you think you're covering it, but sometimes you're creating like new questions, like how did you know that, or why didn't you consider this? And that's the only thing that worries me there. Okay, and then part D, I'm gonna get cut off here in a minute, but we can start this at least. 1 point if you got the second derivative at -5, so the answer to that was -1/2. You got a point there. And then we'll do the other one when we come back from lunch.
Hey, Mark. Oh my gosh!
I'm good. How are you, Mark? Hi, everybody. Yeah. Wednesday. And on our third AP review for 2022. So, I'm Birch Cornelius, Lafayette High School.
College Board is so terrible at explaining things.
Oh my gosh. I'm good. How are you, Mark? Hi, everybody. Yeah.
I mean, College Board is probably thousands of people, so.
I know, but sometimes.
Hey.
Okay. So before lunch, we were checking the last of these answers. So, the last one I had time to go over was part D. Let's see, what was this? This was asking you to find the second derivative at -5 and the second derivative at 3 if they existed. So 1 point came from finding the second derivative at -5. Should be -1/2, so you got 1 point for that. And then this part, f double prime of 3 did not exist, but you also had to have an explanation with that one. So if you had does not exist, and I'll be honest, when I did this one, I said that because there was a cusp at x equals 3, and I don't know if they would quite count that. But a cusp, the same thing is thinking about the slope before and after. Like to the left of 3, it had a slope of 2, and to the right of 3, it had a slope of -1. And that quick change in slope is what makes a cusp. Like that. This has a slope of 2. This has a slope of -1. So I don't know if they would count an explanation good enough on that one to say that it's a cusp. I think to be conservative, I would say unless you went more in detail there, I wouldn't count that last point.
So if I said it's because it's an inflection point, you wouldn't have counted it. So I actually got 1 point.
The problem with that is inflection points can be when the second derivative is 0 or undefined. And the fact that it could be 0 means that that wouldn't be sufficient enough. Now maybe if you said because it's an inflection point and it doesn't equal 0, that might work.
Oh, okay.
But there's nothing wrong with 0, so simply saying inflection point is not enough. Okay, so let's go ahead and, again, I just had you like give yourself a rough score here. But from part A, any of these two you'd like me to go over?
How did you get f of -6?
F of -6?
Mm-hmm.
Okay, well they tell you, I don't have this on my paper, but at x equals -2, they tell you the value is 7, right?
Mm-hmm.
And then to -6, which is what they want, there is this triangle. So did you find the area of that triangle?
Mm-hmm.
And you got 4?
Mm-hmm.
Okay, so then,
Subtracted it?
okay, but why are they subtracting instead of adding?
Well, that's actually my question. Because I got 11 because I added.
Okay, well let's say the picture doesn't look like this, but let's say there was the exact same triangle here, and this had an area of 4. This would have a value of 11, because as you move to the right, you're adding area. But if you're going backwards, it's like there was some value, then it added 4 to get to 7.
Oh. Okay.
Does that make sense?
Yes.
If you're reading left to right, then yes. But if you're reading right to left, then you're going backwards. So it's actually, you should treat this as a -4.
Okay, so then why wouldn't f of 5 be 10 plus 2 pi? Because it would be 7
Okay.
plus 2 pi plus 3. Huh? You've lost.
Okay, I agree with this 3.
Is
This
it
triangle's.
plus, like under the x-axis?
Okay, what'd you get for area on this guy?
Oh, I got 10 minus. Oh, 2 pi. 2 pi.
Okay.
So how does the plus and minus? Like,
I'll come back
Would
to
that be minus to below the x-axis, or is it completely reading left to right or right to left?
Well, there's two different things. If it's below the x-axis, you need to treat it as negative.
Mm-hmm.
So this one you said 10 minus 2 pi.
Mm-hmm.
Okay, was that not the answer?
No, it was, but after you explained how to get f of -6, I was just confused because you're moving to the right, so like.
Okay,
What do
yeah.
you
If
add?
you're reading right to left, which is what you normally do, just like you read a book,
Right.
area under the curve or under the x-axis is negative, area above the x-axis is positive. But if you're going the opposite direction, so this like had a value of 10 minus 2 pi. So we took this value, subtracted this value, added this value. But if you're going right to left, it's like you're going backwards in time. How can the value here be 11 and then you add 4 to it to get to 7?
Okay.
That doesn't make sense.
Right.
You need to phrase it as, what could I add to 4 to get to 7? And that's why it was 3.
Okay.
You should
So if
you should try to read it left to right because that's what we normally do. That's more comfortable.
right, okay, makes sense.
What value do you think it should be?
I don't know. I'm just don't. So
You know the value here is 7 because they told you that.
yeah.
You agree that this area is 4.
Mhm.
Area under the curve is telling you how it's changing.
Yeah.
So if this, think of it like an equation. If this is what you're trying to find, and then you're adding 4 to that, and then it gets you to a value of 7, then that must have been 3. It must have been a value of 3.
Okay.
I'm just saying
So,
if
like,
you're going right to left, you're actually subtracting.
Oh.
Left to right, you're adding. Opposite direction, opposite math operation.
So that's kind of like what they're, because I'm looking at like where they're doing their work there. I think that's where like what's quite following how they're writing that out. Like, do we need to like have it all like that, or can we just do kind of what you did of like, oh, just look at the graph and just kind of figure it out?
Well, based on this one, they expected you to show that you were using the initial condition. So somewhere in your answer, you needed to show where 7 came from. If you went straight to 3 and you didn't say anything about 7 at all, you're not going to get that first point. You have to, like, you could either write it like this or you could write it like this, but 7, well, even that's not good enough really because that doesn't show the 7. You need to show the 7. And then how it changes. Although this one didn't have points for your explanation, so I guess if you showed that you used 7 and you ended up with the right answer, that would be enough. Okay, are you sure?
Yeah.
Okay, other questions about part A? Okay, what about part B? Knowing where F was increasing. I don't think that's too bad as long as you're careful about the graph. The graph was not of F, it was of F prime, and that makes a big difference. More times than not, it's going to be F prime instead of F, but don't assume. Okay, what about C? Absolute min or justification? Okay, what about D? Finding, how did they come up with these second derivative numbers?
The slope.
Right, slope of the first derivative is how you get information about the second derivative. Derivative just means slope. Okay, so now that you've seen the answers based on what you did, as I'm going to keep repeating each time, you need to try and find a point or 2 or 3 if you saw one similar to this that you could get more than you did this time. Unless, of course, you got all 9 correct. Anybody get 6 of them right? 6 out of 9? Couple? Okay, that's pretty good. Again, the average on this one was 3.63. So, you know, if you have 4, that's still great. Still above average. Just the one thing you have to keep in mind on the actual AP test, you might get one like this that you feel good about and you score it above average on, but then the next one you might score below average. You might find it to be harder than the next people. So you still, no matter how good you did on this, you still need to try to find a point or 2 or 3 that you could get the next time if they ask something similar, because more than likely they will. And in fact, as I've talked about before, it seems to almost always be FRQ number 3 too, the first non-calculator. So, of course, there's no guarantee that they will keep up that consistency. Okay.
I have a question.
Okay.
So do they set a timer for 15 minutes? And
They do not.
Do what?
They do not.
Oh, so they give you 105 minutes, or however, because there's 7 FRQs, aren't there?
There's
Right.
6.
Okay.
Okay, they're going to give you
Maybe
2.
I'm thinking about Kim.
You're going to do multiple choice. Okay. Calculator, no calculator, 2 sections. It's kind of like the ACT, but it's all math. Multiple choice. I don't remember if you do calculator or no calculator first in multiple choice.
I was
The third section, you'll get 2 FRQs that are no calculator. So any released FRQ you've ever seen that is FRQ number 1 or number 2, you get a calculator. Chances are you will have to use a calculator to do some messy integration or some messy derivative. So you're going to get 30 minutes for that. Then time's up. Then you come back and they say, okay, now the next section will have 4 more FRQs, and so you'll have 60 minutes. And I don't know if I've mentioned this to you guys before, but the 60 minutes, you have those 4 FRQs. They're no calculator FRQs like these where you shouldn't need one. But if you finish those early, they do let you go back to FRQs 1 and 2. You just don't get to get your calculator back out.
So you need to make sure that you're like for sure about your answers on 3 through 6 before you get your calculator.
Well, just wherever you think you're most likely to pick up points.
Okay.
I'm just saying if you finish FRQ 3 through 6 and you have more time, you can actually go back to FRQ 1 and 2. You can't get a calculator back out, but you might be able to like explain something better.
Oh, okay.
You know what I mean? Like add some justification points or.
Oh, okay. Yeah.
So, unless they change that, but I'd be surprised because it's been that way for a while. Okay, the last thing we're going to look at today, and I don't know that we'll finish the very end of this, but we're going to get pretty close. So there is actually 2 videos that I ask you guys to watch before the AP exam. This is going to be one of them, so I'm about to start a video up here on the board. And part of why there's a million things that we could do that I can think that will help you for the AP exam. But I specifically picked this one, partly because it reviews some limits and continuity stuff, which was the very first thing that we did and is the furthest removed. Usually the thing that students want some more exposure to. 2 is, I don't know that some of you guys know that College Board puts together these review sessions. So these are actually from 2022, but of course calculus, limits, and continuity has not changed in the last year. It's still the same old stuff. So this is going to be the one that I require of you, but if you notice on the front page, I went ahead and made some nice short links for the note handouts and videos for the other review sessions from last year. So what I'm hoping is that some of you think this is helpful, and then on your own you say, you know what, I don't feel comfortable with the big theorems, IVT, EVT, MVT, maybe I should watch the live review number 5. And I put that link on there so that you can do that. So I'm halfway trying to convince you guys to use this as a resource, but also it's a nice, quick way to get some help with limits and continuity. These 2 people are both very famous. In fact, any circuit that we've done this year, that lady is the one who has made it. She is, these people just kind of lead the charge nationwide with calculus. And when COVID came around and, you know, everyone was at home and some schools were told that they were not allowed to teach anything new, and students had them, you know, a month before the AP test and their teachers weren't allowed to review or anything. Different schools handled that differently. College Board paid them to make some videos, and they've been very well received, so they continue to do that. In fact, this year I think they're doing it again, so there will be videos for 2023. So, you know, I'm certainly not discouraging you from watching those as well, but the 2023 version of limits and continuity is probably not much different than the 2022 version. But these 2 people work for College Board. They know exactly what they're doing, and I've never watched a full one of their videos before, but they are, I don't know, they have a good relationship. They make it a little bit more interesting than just working random questions. All that you have to do is you have to pay attention, and then on the other pages, this is the same handout that they're going to go over, so you just need to follow along and basically try the ones they ask you to try and take notes and try to fill in the gaps and make sure that you remember this stuff, or try to learn a few things from it. Now again, I don't know that we will quite finish, but if we don't, we can finish at the last few minutes another day. So, all right, before I hit play here, any questions about expectations? Claire, these are not the 2 people you've seen, is it? These are not the 2 people you've seen on College Board before, no. I hope. I can't speak, like, I know that they do these live sessions, these live videos and stuff for other AP classes. I can't speak on how good they are, but I know these 2 people pretty much live calculus. I mean seriously. She makes all those circuits, and he answers teachers' questions on Facebook like every day, like dozens of questions.
Have you asked him anything?
Huh?
Have you asked him anything?
Have I asked him anything? No, I don't think so. Like the first year or two that I taught it is probably when I had questions, but I didn't want, sometimes if you don't know, like asking a question there's a good chance you're going to sound dumb if, you know what I mean? Like if you're asking a question that everybody else knows. So I probably didn't ask for that reason, and then after a couple years, like anything I needed to know, I know by now, so. Okay, I'm going to hit play, so please, and I'll turn off the lights here, but please follow along, and I will stop it a few minutes early to make sure you know what I expect out of you for class tomorrow.
Oh my gosh! I'm good. How are you, Mark? Hi, everybody.
Yeah.
Welcome to Wednesday. We have our 2 days in, and we're on our third AP review for 2022. So, I'm Birch Cornelius, Lafayette High School, Oxford, Mississippi. I'm Mark Corelli, not Lafayette High School, in Denton, Texas. And here we go. Yeah, what are we doing today?
Yeah. If
I remember correctly, it started with an L.
Yeah.
So we're in retrospective, right? This is going, taking it all the way back. Sometimes somebody to freak out about it. Yeah, and I think too, applications with limits, including but not limited to. Okay, let's see what's coming up here.
Yep,
Definition of derivative. Ooh, my favorite. Me too. You taught it to me really well, actually. As a teacher.
No.
As a teacher.
Yeah.
And L'Hopital's rule. L'Hopital's rule.
So,
big data day, because we're going to do limits with an understanding of calculus instead of doing limits to develop the calculus, which is really how they present themselves in the course, but it's not how they're necessarily tested. So, anyway, big day. Time to warm up. So did a warm up, guy. Great. Alright, today's warm-up has the choices there, because without the choices, the question doesn't make a lot of sense. Consider the function f of x equals x squared minus 3x plus 2 divided by and just respect the fourth order x squared.
Is that one on there?
The following statements are true.
It should be right after this.
Fx is 3 vertical asymptotes. Fx is 2 vertical asymptotes and 1 removable discontinuity. Fx is 1 vertical asymptote and 2 removable discontinuities. Or f of x has 3 removable discontinuities. So we need to figure out a plan of attack on this. You told me to consider the function, and I always put it over here. And I think too, one thing I would like to point out is there's no calculator icon there, which means that we have to do this by hand. We have to really understand what's going on with this rational function by hand. So that's exactly what Mark's about to do. He's not going to go to his calculator right now. And of course on the real test I won't have to recopy it, but it makes it easier if I'm looking at my page that I don't actually plan to do. You know what I call that though? I call that like addressing the problem or kind of like getting into it a little bit. Like I actually like to rewrite it, even though I know what I'm doing, because it helps me kind of get into the problem. I don't know why. I always do it though. I promise we'll get this to work. It's all in front of your mind. Okay, so we're gonna factor these, right? We need to find out where things are zeros, where zeros are, both the numerator and the denominator. So factor the 2 that add up to -3. So 2 prime, that's pretty limited set there. Limited. Unintentional, but we'll be using the future. I think I should start keeping score. So we got x minus 2 times x minus 1 in the numerator there. Or these nice students know I call it the inverse operator. And then on the denominator, I've got a common factor of x squared. X squared minus 4. No, that should be setting off bells and whistles in all your experience factors. That is a different squares, moves, and then conjugate pair of x plus 2 and x minus 2. And then this is what we really want to consider, this form of a function. It's a rational function, we're going to try to keep those linear factors out, or you're not quite factors. Looking for pairs, right? That's the thing that math.
Yeah.
So remind me, what happens when those match there?
They divide V1 as long as x doesn't equal 2. Oh, wait a minute, I think I know what's going on here. And this is going to cause a removable discontinuity. It's kind of going off screen, but you can hear what we're saying, removable discontinuity.
So we got a removable, that's cool. Alright, sweet. So we know it's not A anymore, right? And it's not going to be, well, actually we're kind of done, because none of these others are going to remove it, but let's continue and confirm. X equals negative 2 creates a 0 there, but it's non-removable. So that's going to be a vertical asymptote.
Yep.
We have a non-removable denominator. And similarly, at x equals 0.
That's right. So 2 vertical asymptotes, 1 removable discontinuity. Excellent. Yep. Choice B is the answer. And like we've said a million times, and I'm sure your teachers say this kind of stuff too, as we move forward, you definitely want to pause the video and try and work it for yourself, and then kind of hear what we have to say about it. And I think the next slide, Mark, is maybe where they can get the problems that we're going to do this session.
Right.
Yeah. So we got to practice.
So that'll pick it to Wednesday, Told?
I'm not going to pause the video each time. That way, y'all can just follow along.
Where you can find your gaming problems then.
Yeah. And I'd like to say too that it depends on how much time you have. But if you have tons of time, I might do all the practice first, and then watch the video and see how you did. Unfortunately, we didn't get to a lot of stuff yesterday that we wanted to, and that's okay. We'll come back and visit some of those things. But we have a plan of what we want to cover today from our practice folder. So I'm going to switch screens right now and go to my overhead. Am I right about that?
Here we
Here
are.
we are at
You.
Yep.
Am I visible here? It's all looking good.
Down there, it was really good.
Okay. So we can see the note calculator icon, and I'm going to do several of these on the first page. And also, I did want to tell a joke, but maybe I'll wait until Mark steals the screen again. Actually, while he's in the process of stealing the screen, I'll tell a joke.
Come on, you
guys are desperate waiting for a math joke, right? Okay. Anyway, here's our first one. And there's many ways to talk about this one, but this is find the limit as x approaches 2 of x cubed minus 8 divided by x minus 2. And what you would want to do first here is, and any kind of a limit like this, an analytical limit, is you would want to substitute in, and here I go writing it again, you want to substitute in the 2 to the numerator and the denominator. Well, my numerator becomes 8 minus 8, which is 0. And my denominator becomes 2 minus 2, which is also 0. So this is an indeterminate form, and so I can't conclude anything by direct substitution. So maybe I would factor and cancel, or use synthetic division or something like that there. Because we don't know if this is a removable discontinuity or what's happening there. Okay. But we do know about L'Hopital's rule.
I actually had another teacher who mentioned something, and I thought this was really cool. It never occurred to me. If you substitute the denominator first, you'll know whether the direct substitution even has a chance of working, right? If you can zero the denominator, you know things are going off the wrist.
True.
This is a way to think about it.
Yeah.
It naturally works top down, but there's no reason not to go down up.
True, but if I want to use L'Hopital's rule, I definitely need a 0 in the numerator as well.
I prefer both.
Yeah. And I'm being pretty loose here with my notation, by the way. I'm just saying, if I had to justify something, I wouldn't be doing this, but this is a multiple choice. So I'm going to go ahead and use L'Hopital's rule, even though if I could do it a ton of different ways. This does qualify for L'Hopital's rule, so I take the derivative of the numerator, I get 3x squared, derivative of the denominator, and I get 1. And I substitute again. And you can do L'Hopital's rule as many times as you're still eligible. And sometimes it happens 2 or 3 times that you continue to take those derivatives and then finally arrive at your answer. So I'm getting 3 times.
Bert said that really quick, but you make sure that it's still a 0 over 0 or infinity.
Oh, yeah. And there are cases where you do continue to get the 0 over 0 or infinity over infinity, but L'Hopital's rule isn't helping. You have to, you have to like abandon that mission and try a different kind of analysis, numerical or whatever, because it's not working for you. But in any case, this was a one-shot deal, and there you have it. That's all I needed to do, and I'm seeing that the answer seems to be A. All right. Number 2 has a graph. Interestingly, it has this asymptote right here, vertical asymptote. It looks like it's x equals -3. Looks like it has some sort of a jump discontinuity here. It's x equals -2. And at x equals +2, we have this removable discontinuity. Even if that point weren't there, it would still be considered a removable discontinuity because the limit exists as x approaches 2. So it says here, I kind of read the graph, and now I'm going to see what I actually have to say about it. The graph is actually shown at what value of x does f have a removable discontinuity. Well, Mark, were you paying attention or drinking your tea?
I'm pretty sure you. It's actually peppermint cocoa. Thank you. I stocked up before they ran out of the Christmas supply months ago. Yeah, you said it very well. At +2, we have that removable because that limit doesn't exist. At -2, we have jump discontinuity because you have left and right limits, but they're not the same. And of course, the asymptote is very well drawn.
Very good.
Kudos to the person who
Kudos to you who drew it, yes. Okay. Oh, that's right. I'm going to skip number 3 because it'll be a great one to do with your class or with your teacher, or maybe we'll come back to it when we do a recap later. But I am going to go to number 4. I'm going to do a little bit of folding math here. And the reason I'm going to go to number 4 is that last night when we were talking about what we were going to do today, I'm like, oh, no, we're not going to do number 4, it's too easy. And then I got it wrong this morning when I was checking my answers marked by email. And so I think we need to do number 4. It's
what's funny is I got it wrong first, checking on your answers from a week ago. Then you spit the wrong answer. You actually got to check by yourself in a roundabout way.
So I think that once again, our score is a lot to a lot, right? Okay, so here's what if you've done this problem, or if you've looked at it a little bit just now and you've thought about it, the issue is you might think that all we're doing is thinking about the limit as h approaches 0 of cosine of x plus h minus cosine of x all divided by h, and we're just interested in what this value is, or what this expression ends up being, or what have you. And this is actually the limit definition of the derivative. This is saying, go ahead and figure out the derivative of cosine. Okay, that's the limit definition of the derivative. But instead of saying, okay, the derivative of cosine is negative sine of x, which is what I put originally, it's not the correct answer, this is being defined as a function, and we're being asked for p prime of x. So yes, p of x is equal to the opposite of sine x, because back from a long time ago, I don't know if you started school back in August or September, this would have been that limit definition of the derivative. There's 2 different ones actually, but that's one of them. And so I can see structurally here that the cosine is the function. And so I'm just reading this as, oh, they want me to take the derivative of cosine x. There it is, negative sine x. But really what this question is saying, what's the derivative of p? So now I have to differentiate one more time. So Mark, derivative of the opposite of sine?
Cosine. Well, opposite of cosine is the negative sine.
Yeah. Yep.
Yeah, I agree with this. When I wrote it, when I did this morning,
Did you have a question?
Wait, no, I don't get that.
Because
if you take the derivative of function,
x,
though, right?
you get
It's
negative
like,
sine x.
it's the
Okay, but so what she's saying is this right here This stuff is saying take the derivative of cosine, which would be negative sine.
Right.
But that's what p is. P is negative sine. The question is, what's the derivative of p?
Yeah, the derivative of p would be negative sine x.
But that's
No.
not evaluated.
No, this stuff, this limit here, this is the limit definition of a derivative.
Right.
This equals negative sine x.
Wait, how?
Oh, I see, because that's like the function f.
Yeah, right here, this is the function sitting here.
So the function's just cosine f.
Yeah, the function is cosine, so the derivative is negative sine, right? I think we're okay with that. The part that you guys are not, I think that you're not getting, is that is what p is equal to. But the question isn't what is p, the question is what is the derivative of p. So it's like there's two derivatives here, and that's what makes it tricky.
Well, if f of x, if negative f of x is equal, or I guess if f of x is equal to cosine x, and then wouldn't you just take the derivative of negative cosine x?
Which
And
is,
you get the derivative
and then you get what?
px? What do you get? You get sine x, right?
The derivative of cosine is sine?
Or, no, it's negative sine, but negative cosine of x equals sine x.
Okay, so that's what p is. That's equal to p. What's the derivative of that?
Negative cosine x.
This. This is telling you to do derivative on the right, define p, but then the question says, what's the derivative of p? So they're actually doing derivative twice. Once from the definition and once from the other part.
Oh.
That's a pretty unusual question. The second half of that, that's kind of tricky. You don't need to worry about.
I basically did, I wrote p of x equals v over dx of cosine x.
But I missed that one too, so I didn't pay that close attention to
To
it.
that differential notation of d over dx cosine x.
Okay.
That helps
It
you.
cemented it for me.
Good.
By the way, I had mentioned, and I made a big mess of it before, I had mentioned that as you prepare for a big exam, whether it's this exam, or I'm sure you might even be in some other AP classes like AP Chemistry or something like that, and you're making your own personal study guide, it does you no good to know what's on my study guide. That's important for you to go through your notes and your notebook and your everything else and make your own study guide. So for trig derivatives, if y is equal to the sine of x, then y prime would equal cosine of x. And those are things that I might have on my study guide. Anyway, I just wanted to show you that. We call it the yellow sheet in my classroom.
Mine would say cofunctions have negative derivatives.
Cofunctions have negative derivatives. Yes, so for example, the derivative of cosine, cosecant, and
How do you say it? Okay, I'm pausing here because I want to make sure that you guys know what the homework is. Again, I know everything's a little bit more scattered here. This last month where I tried to get in as much practice and help you guys with as much as possible, but also get in a bunch of grades, because after the AP exam there'll be little to no grades. So the handout you picked up today, number 117, when you see this is what you do part 3, there will be another mini quiz over that. I think that'll be probably the last one of the new ones of those. So like the first two, I hope that you remember all of it. If you don't, you should still remember most of it, but be able to at least do a matching quiz for the ones you don't remember. A couple questions may come from part 1 and part 2. That's why I grade those and get those back to you, so if you're making mistakes, you can learn from them. Then finally, 115, that packet of 4 FRQs, the only other thing you need to do for homework is the last one I'm leaving for you to do. So you can time yourself. There's a link for you to check your score and check the answers, and a link to a video of someone working it out, and you can skip around and get the help that you need. But you should have all of this 115 done and study for that mini quiz, please. And it is a B week, so I will see you again tomorrow.
Track meeting, can I go?
Do you have school business?
Yes. Well, for